So welcome back. We're going to start our second session. I'll just give a quick announcement. Well, perhaps it's not the best time since not everyone is here, but well, we can repeat this later. We will upload all recordings on YouTube. And possibly we will also upload presentations if the speakers agree at the conference website. We'll try to notify you by email. I'm not sure whether the Zoom platform allow me to send mass emails at the end of the webinar. Otherwise, please keep an eye at the conference webpage. I think it will keep a couple of weeks to do so since I'm traveling to Ghana tomorrow, so I'll do it when I come back. Okay, I'll shortly introduce the chairperson for the next session, Dr. Penda Diallo. She's an expert into the interaction between mining, quarrying activities, society, and politics. She's been actively working in several places in Africa. She's been formerly a researcher at the University of Exeter. I think you recently had some change to your affiliation. So if you want to to complete your introduction by yourself, and okay, thank you, Penda.
Thank you, Luca, and thank you for inviting me to take part into the session and to chair this session. So yes, I'm presently a lecturer in sustainable mining at the University of Exeter. And yes, and my interest lies at the intersection between mine, society, and politics. So thank you very much and welcome to all of you again. I hope you had a good break. So our first session will be by Nonkuleko Radebe, who is not here. She has sent, I believe, a recorded presentation. And Nonkuleko Radebe is a PhD researcher at the Karlsruhe Institute of Technology. So yes, I think we can put on her yes, her video and
okay, I'm going to share the now my screen with the video. Okay, in case, just send me a message if there's any issue with it.
Hi everyone, my name is Nonkuleko Radebe, and unfortunately I won't be joining the workshop today, but I thought it was still very important for me to share my presentation. And it is titled Building an Interdisciplinary International Network, specifically as a young researcher. So I am a PhD student at the Karlsruhe Institute of Technology, but this is not a presentation, or rather a technical presentation based on my actual research, but rather a wider, more important, I think, topic on building a network, specifically as a young researcher or a newer researcher within sustainability and sustainable construction. So my background is chemistry. I studied chemistry and polymer science at the University of Stellenbosch in South Africa. And one thing that is quite typical of chemistry and its modules, both on the African and European continents, is that you have your normal chemistry modules like in organic, inorganic, analytical and physical chemistry. But it's very rare to find that all of these modules or core modules incorporate sustainability aspects into the modules. What normally happens is that you'll have maybe 1 week where it looks at sustainability within those modules, or you'll have a topic or a module rather, like called special topics or something, where then it will look at like recycling, or it will look at whatever sustainability measures are within those subjects. But typically it's very like an afterthought. It's not really well incorporated into those subjects. And I think it's important to move towards a curriculum that incorporates them quite aggressively, because we're living in a world where we need to educate young people about the issues that we have right now, specifically with regards to sustainability in all subjects. So not only within the construction industry, but also within plastics and in everything else. What's important also is that we need to constantly think about the fact that all sciences rather are interconnected. So within chemistry, you'll find physics. Within biology, you'll find chemistry. Within geology, you'll find physics and environmental sciences and so forth. And these are all subjects that are basically interconnected, but generally studied in isolation to each other. So it's very difficult sometimes for students specifically to see kind of the link between these subjects, although the links are there, very clear. And we learn all kinds of theories and concepts within these, different modules about, energy. In physics, you learn forces. Even in engineering, depending on, if you're doing civil engineering, you learn about certain forces that shouldn't be exceeded for maybe like a bridge to be built and so forth. You learn about vectors and gravity and all sorts of theories and concepts. And basically all these theories and concepts describe this world that we live in, this beautiful planet that we all living in right now, right? However, we need to consider, and we all know this, hence actually why this is, part of this workshop, is that we are facing a rather huge problem as a planet, and that's the big foe of global warming. So with global warming, we know there's increased CO2, which leads to melting glaciers, which leads to some land masses in certain areas actually submerging, and you're actually losing land mass, and people's livelihoods are being completely destroyed. You have all kinds of changes in agricultural patterns, which then cause famine and hunger in certain parts of the world. You have all kinds of ecosystems that collapse, which also then plays into agriculture and migration patterns of animals and so forth, and even of people. However, considering all of this, we cannot avoid the fact that on the African continent, we are still growing. Therefore, we still need to build sustainably. And that's really the core message, is that we need to do this sustainably. And the question is, okay, what does that entail? What does sustainable urbanization actually look like? And how could we do this in a more interdisciplinary approach? So a lot of the time we talk about multidisciplinary, and I myself speak about multidisciplinary a lot, but multidisciplinary just means that different disciplines exist. It does not necessarily mean that these disciplines play into each other. It just means that they are all within the same space. So you will have civil engineers doing civil engineer things. You'll have architects architecting. That's not a word, but you'll have them, designing buildings and so forth. You'll have city planners planning for the future and so forth, without necessarily interacting very intensely with maybe, the architects or even the people of that place in which they are planning for, or even material scientists to find out the most sustainable types of materials that can be used, and working together with civil engineers to see, okay, are these materials bearing enough load for XYZ and so forth. All of this is generally widely done very separately. And I think we all know that this has to kind of be more interdisciplinary, where all these different fields kind of play into each other and actually sort of, work together in a way. It sounds super kumbaya, but that's actually the only way that this approach could work and actually become more sustainable. Because without material scientists, engineers don't have no materials to then design for, and also architects that are like designed for more sustainable types of designs and so forth. And without the people that are actually going to live there, it's very hard for city planners to incorporate the needs of the people, whilst also incorporating the designs of the architects, blah 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 and so forth. But the point is to in order to have an actual puzzle that fits into each other, we have to kind of work together simultaneously, not as separate entities on the same project or so forth. And an important way of cultivating these types of interdisciplinary conversations and actions within research. I mean, I am a researcher myself, so I'm looking at it more in this regard, and how to build these kind of environments. And one example is in 2019 we had a sort of a conference in Nairobi entitled Innovation, Science, Engineering, Education. And it involved people from everywhere, not only everywhere in the world, but every kind of a profession that's related to construction. So you had actual engineers who are field engineers, you had researcher engineers, you had architects, you had also social people within social sciences and so forth. You had, chemists like myself, students, professors, like just people from, or city planners, people from all different, realms coming together to discuss several different topics, which were divided into quite a few interesting interactive workshops. And I luckily led one of them. It was called Global Research and Education Requirements. And this is actually where I met Luca. So yeah, that was really lovely. And yeah, thank you for inviting me, Luca. I think I said this already, but yeah, so these are the different, workshops and interactive spaces that we were all a part of. Some of the sort of questions / requirements that then came out of this workshop was that we really, really need more functionally educated researchers. So researchers who research things that are applicable, we also need more, mobility and exchanges between institutions. And as I mentioned earlier, also adding, sustainability components into like generic modules like chemistry. And also creating awareness through different types of teaching methods, not conventional teaching methods within a classroom or virtually like this, but actually actively on site, but not necessarily following the book to the T, because not all spaces allow for standards and so forth to be used in all spaces. I just also want to highlight that the group itself was made up of people from different countries, different ages, different professions as well. So it was really quite a diverse group of people discussing this topic. And some of the solution strategies was, okay, we need more researcher mobility, things like the Erasmus Programme, which is really helpful for lots of people, to include more like complementary types of subjects within your subject. So even if you're studying engineering, you should have, some kind of social work, or I don't know, some social type of science within your core science, so to speak. And most importantly, also to improve the relations between industry and researchers, because I think a lot of research is being done in the labs and it's being literally kept in the labs. There's very little kind of transfer of knowledge between researchers in the lab and industry. In some places it's more than others, but it's really not at the rate that it could be, and it could be more impactful. Another thing is, as I mentioned, interdisciplinary and intercontinental research. So not only within your spaces, having interdisciplinary types of interactions, but also within different continents, because I think in this way we can also learn quite a lot from each other, not only scientifically, but culturally, and build all kinds of tolerance and things like that. And also push for more improved funding for research. And there's some really interesting statistics of how adding more funding into research really has a direct correlation to the growth of an economy. So this is obviously very, very, very important. Here I'm going to also just introduce a new project that we started recently. It's called Falconess, and this is the logo, which is very right on the cheek, Falconess bird, but actually it stands for Female Academic Leadership Network and Conscious Engineering and Science towards Sustainable Urbanization. Super mouthful, but actually what it's about is researchers answering scientific questions that are related to sustainable development, specifically in Africa. And basically building a link between engineering and scientific topics, whilst also adding the socioeconomic aspect within this. And the project looks at 5 major cities, or at least some of the fastest growing cities in the world, which include Lagos, Dar es Salaam, Cairo, Johannesburg, and Accra. Some of the aims of this project is to create these networks between female academics and professionals, as well as international decision makers, and also study a wide range of African cities, because as we know, Africa is not a monolith. What happens in one city or even in one country doesn't happen in another, and what happens even in one city within a country does not, apply to a city within that country as well. Another important aim, or at least mission of the project, is to connect expertise from a wide range of not only STEM subjects, but also socioeconomic subjects. So the group itself actually comprises of people with a wide range of disciplines and backgrounds. So you have, people who are in economics, others in, sustainability, environmental sciences, core like chemistry subjects, physics, engineering, and so forth. And one of the most important parts, I think, also is to connect different generations, as in people who are not within the same age range, or basically age range, to connect them on. Those people also need to sort of connect and build this, these networks, because I think the transfer of knowledge sometimes from generation to generation is only kind of left to the classroom, from a professor to a student, but you can also from a student to a professor learn, and so forth. And just to develop more synergies and interactions and networks, specifically within research activities. And this is a project that is quite new. And if you want to follow the updates of this, you can follow it on falconist.org. Another organization that I recently became a part of is RILEM, and I think RILEM had a short presentation earlier, so I won't go too much into what RILEM is or what RILEM does. But what I wanted to specifically highlight is that there are these technical committees which are for technical exchanges and writing things like state-of-the-art reports of certain sort of new research or new directions of research. And there's two that I'm a part of, but I think one I wanted to focus on specifically is the one titled Use of Agro-Based Materials as Cementitious Additions in Cement and Cement-Based Materials. Also another mouthful. But essentially what this technical committee does is it focuses on looking at agro-based materials as replacements for cementitious materials, or at least additions to them, in regions where manufacturing cement is really already quite expensive, or certain super plasticizers are not available because they are expensive and they require transportation and so forth. So using these agro-based materials not only as cement replacement, but part of it as also plasticizers. And it focuses specifically, or at least mainly, on the fresh cement cement and concrete properties in the sort of early ages, and also then to promote the use of agro-based materials and not just have it as something that is just research. And just to kind of add on, we recently started a new sort of subcommittee within RILEM called the RILEM Youth Council, and I'm the representative for Sub-Saharan Africa. And basically the aims of this youth council is to encourage to have a younger and more, not younger, but also involving of younger researchers within RILEM activities, and building a network of young researchers and showing them, or at least promoting the benefits of having this kind of network. And if you want to find out more about that, you can follow us on Instagram at RILEM Youth to find out more, and we post bi-weekly, so we're quite active. Then you can also just DM us if you have any sort of specific questions and ideas. And on top of this, we're also trying to build a sub-Saharan kind of region of the RILEM youth community. This is just a screenshot of a brainstorming session that we had on how to actually get more African youths involved in sort of committees or communities like RILEM, because they're quite beneficial, but it's sometimes a bit difficult to involve young African researchers into such societies, because I suppose many see it maybe as a European society and they don't necessarily see the benefits immediately. So we are trying to kind of incorporate needs of younger African researchers within RILEM and find different ways of approaching it. So I'm also happy to discuss this more with people who have ideas and who also want to join this sub committee / community. So I think I've come to the end of my presentation, and just want to summarize by saying, okay, what's the approach, or at least my approach, and how it's worked for me so far. What's important is you need to consider, okay, what are my expertise versus my interests? As I said, my expertise are in chemistry and in polymer science, but my interests are now in construction and sustainable construction. Then the next question is, okay, does my current network align with my interests? and mine not necessarily because it's very core chemistry. And for this reason, I decided to join like more external societies and projects, and hence all the 3 projects that I just mentioned. And more than anything, just being a part of these communities or societies, that's not how you spell societies, being part of these societies is not enough. You have to also be quite interactive within them, and participate actively within them, which is also something I'm trying to do right now. So what's the take-home message? The take-home message is more of a take-home question. It's about what links are missing within your network. How can you then close these gaps through different, projects and societies and all sorts of things outside of your already formed network. And more than anything, if it's important to you, then it should be not so difficult to go about. So thank you so much for listening to me. I really hope you learned a thing or two. If you didn't, it's also fine, I guess. But yeah, thank you very much for listening to me. You can always just email me if you have any specific questions, or you want to just connect and link up and maybe share ideas. Yeah, I'm really open to all of that. And yeah,
Thank you. Thank you, Nonkuleko, for this great presentation. And you've touched on very interesting aspect, and particularly when it comes to the need for interdisciplinarity, and because we talk about sustainable development and sustainability, but there is a gap in most curriculums. I am a lecturer in sustainable mining. I teach this to engineers, and quite a few of my master's students come to me without ever touching anything to do with sustainability. And they find it very interesting and aspiring, and they wish they had touched on it earlier. So I think it's something we need to catch up on, both in the South, but also in the North. I mean, in all the education systems, basically. So if anyone has questions, can you please put them on the Q&A? And I'm sure that Nonkuleko will be very happy to respond. But in the benefit of time, we will go to our next presenter, who is Federico Monica. Federico has substantive experience. He's an architect. He's worked in various places in sub-Saharan Africa. And it's also interesting to see that he has a vast experience working with NGOs and international development, because often we don't necessarily always think about the roles of architects in these sectors. We don't see them a lot. So welcome, Federico, and thank you for agreeing to present today.
Thank you, Penda. Thank you to Professor Luca and Joseph for the invitation. And I'm going to share my presentation. I think, okay, I think you should see it now. Can you see the presentation?
Yeah.
Okay, wonderful, thank you. So I'm Federico Monica. I'm a PhD and an architect and an urban planner, and I worked and I'm working especially in sub-Saharan Africa, and especially regarding the informal settlements and the effects of urbanization. I'm here today with this presentation, especially to take you in a small tour, and thanks to a project that I recently launched that is called Placemarks. And Placemarks is a project that works essentially on satellite images, and has the aim to assess the changes that are taking place in landscape, in nature, and in ecosystem across the African continent. We all know satellite images because they just became one of the everyday tools for us researchers and experts. Until 25 years ago, they were almost reserved to researchers. Now the situation is so different, and we will see why and how. We can use satellite images in a broad range of sectors, of course, urbanization, environment, agriculture, mining, infrastructures, and for a broad range of activities, traditional activities like planning, research, designing, the evaluation and monitoring, until the most promising innovation like artificial intelligence that is allowing writing some algorithms to in real time monitor the changes that are taking place in our planet. But I will tend to focus more on the opportunities that satellite images has and give for everyone, because since 2008, 2010, we have a lot of tools that are completely free, that are completely accessible. We will see some of them in the last part of the presentation. Maybe all of you knows Google Earth or Google Maps. And now, today, those tools has also a really good resolution and a really good coverage in all the world, and especially also in all African continent. So we have a good resolution that allow us to recognize single buildings or vegetation cover in the great part of African continent. And this gives a lot of opportunities and give also the opportunity to develop simple elaboration or awareness campaigns. So, as I said, let's start with some images. I titled this "A Tour of Hidden Impacts of Urbanization and especially of construction sector like cement production, quarrying, informal quarrying, or sand mining." A tour of hidden impacts because it happens that many times these impacts are not visible by the ordinary horizontal level, and we have to have an overview to see what's really happening around us. The first example is in Senegal. We are not far from the capital city of Dakar. We are around 50 kilometers from Dakar, near another important city in Senegal that's called Thiès. And we can see this is an ordinary road. It seems an ordinary road bordered by vegetation. The only difference is the color of the dust near the road, because usually is dark yellow. Here is more white. But the impression is to passing through an ordinary landscape of forest or of savanna. And if we look at the place from the above, we can see that the reality is so different. We have just a small strip of vegetation around at the border of the road, and we are close to one of the biggest cement production plants of the country. Just to let you understand the extension of this plant, you can see on the right a small red rectangle that is an ordinary football field. So just to understand the extension we are talking about. And this is the cement plant production is particularly concentrated in the Dakar area, and even from the space we can see clearly where those areas are located, and we can see those white spots are those big quarrying areas that are used to alimentate the cement production plant. Dakar is growing fast, and the demand for cement is of course so high. We change country to go to see what's happening in the one that is said to be the biggest cement production plant of the whole Africa. We are in a small, really small town of central Nigeria. It's called Obayana. If I'm spelling wrong the name, I ask Nigerian friends to correct me. And yeah. It's correct. Okay, thank you. And this is just in the middle between Lagos, the economic and demographic capital of Nigeria, and Abuja, that is the political capital. And we can see here we have an enormous cement production plant that has an extension that is similar to the one of the whole town. And this is the extension just of the production area, because the quarrying area is far 10 or 15 kilometers. But I don't want to concentrate about this extension that is of course normal, because the demand of cement is high, and of course these industries has to give an answer to this demand. But I want to concentrate to another aspect about impacts that became clear looking at this aerial view. And that is the one of the transportation. In this small animation, we can see how many trucks are parked around the city and around the production plant, waiting to carry the cement, the bag of cement, and to bring it in other places. We can see the whole streets of the town are full of trucks, hundreds or thousands of trucks in line, waiting to enter inside the plants. There are several entry points, and all of them are completely crowded of hundreds of trucks and of vehicles waiting for to load cement. And this seems an ordinary situation, because even in images taken in different time of the years and in different years, we found that we had a lot of trucks in line and in these enormous parking areas around the town. So this let us know that in this particular case, the transport question and the transport environmental impact is probably the main one, even measured than the impact of the plants itself and of the quarrying itself, because we can see really a town that is completely overcrowded by this truck and mean of transportation. We change country, and we just take a spot to Addis Ababa to take a look on the problem of quarrying. In this case, it's quarrying of gravel, of small granite stones. And we can see a quarrying mine that is really, really close to the town and to the buildings and to the houses of the town. The situation is in Addis Ababa is particular because we can see this is another one of the fast-growing African cities, and we can see the extension. The part of light gray is the built environment of Addis Ababa, and we can see the shape of the city. And it's interesting because by a quick research and a quick search of quarrying areas in Addis Ababa, both formal and informal, we found these areas that often they collide with small rivers or canyons. And what we see by these images, we see that quarrying areas are, in a certain sense, giving the shape of the city. So the extension, the city of the Zababa is surrounded by these quarrying areas. And for us, urban planners, is strange because we are used to think usually to the concept of green belt and to see cities surrounded by green areas to protect ecosystems and so on. In this case, many African cities are surrounded by gray areas because, as we know, quarrying remove the fertile layer of the soil, and so vegetation cannot grow even for a long time. And to repristinate the soil is a long and expensive work. So this particular situation we focused on Addis Ababa, but we can see this situation in many towns in the continent. It is not just, as I said before, a problem of industrial quarrying, but also of informal quarrying. Here we are in Accra. We can see the effects of the sprawl, of urban sprawl. So houses growing quickly without infrastructures, without proper orientations. There is almost anything, but we can see how the soil is dilapidated because the great part of the top layer of the soil are removed and are used to make foundation, to make pavement for more roads, and it's ordinary in the belt of sprawl to see a really dilapidated ground caused by this informal quarrying. Another situation that I would like to focus on is the dredging. Here we are in Abidjan. We can see dredging activities in the port channel of Abidjan. Abidjan is a particular city because as many colonial capitals, former colonial capitals, has been built in a lagoon area. So part of Abidjan is built on islands, part on the highlands, and there are a lot of bridges that try to connect the different parts of the city. The same problem regards the port of Abidjan. The port of Abidjan has not a unique hub, but have different quarries in different areas of the lagoon because there is still no room to concentrate all the activities in one place. And in 2015, the government of Ivory Coast started a very big program of port development, finalized to improve a lot the capacity of the port. And this program is based mainly with extension that is possible to obtain with dredging material, the materials resulting from dredging of the lagoons. We can see what happened 6 years later. So now the aspects of the city of Abidjan is this one. We can see a lot of areas of the lagoon have been filled and will be used as container depots or so on. We are talking about 250 hectares, and we can see how the shape of the lagoon changed completely because this is no anymore a lagoon, but it became a system of small lakes and narrow channels that are connecting each other place. Considering also all the problems that I think you know better than me, that the use of dredging materials in a port area have especially environmental problems. I want to close my presentation talking about a small informal activity, but that can have important, really important effects on the landscape and on ecosystems. And this is sand mining, informal sand mining. Here we are in Sierra Leone, not far from the capital city of Freetown, and we see a line of trucks with people around that are filling this truck of sand to sell the sand for building and construction activities. We all know that sea sand is not proper for building and construction activities, but the use of sea sand is ordinary in many countries as Sierra Leone. Here we are not so far from the beach that we have seen before. We are in a location in a beach near a town called Bure, not far from Freetown, 30 kilometers from Freetown. And this is 2015, a 2015 image, and this is the first image when that we found with two trucks. You can see here in the red circle. With two trucks that are mining sand. So we can say that activities of sand mining starting in this particular area in 2014 or 2015. And just we can see that the area is still so natural. We have still some part of rainforest and few construction. We can see how the situation changed already 4 years later. And 4 years later, we can see that we have still activities of mining of sand, and the forest reduced a lot. And the last image that we have is more and more interesting, because we can see how the erosion of the coastline is rising exactly when the activities of sand mining are developed. And with this elaboration, you can see how the changes that that we had in this period of time. So I show you a lot of images and a broad point of view about this problem in different countries and regarding different situations. And this activity, our activity, is based, of course, on the research and the scientific research about this phenomenon, but is based especially on the dissemination of awareness and on the dissemination of active citizenship. We know that there are a lot of free and open research tools. I talked about Google Earth, but it's not the only one. There are a lot of tools here. You can see some of them, and that are easy to use, free, and available to everyone. And we are starting to propose some program of training to help the self-assessment. We think that the great opportunity that these instruments are giving to us today is the dissemination of awareness and the opportunity for local communities, for ordinary people to self-monitor, to self-assess what's happening in their community. So we are trying to develop training module that can teach how to recognize what's happening, how to recognize if something wrong is happening in the community, and even to collect proof if in future there will be litigation or so on. Just to leave you with an example, as I know that many of the attendants are from Meru University, I did a quick research on Meru area. Here we are around 10 kilometers from the center of Meru, in a village called Gaitu. And this should be the airstrip of Gaitu. And in this image of 2015, we can see an ordinary rural landscape where we have for the grid part cultivation. But if we take a look for a picture of 5 years later, 2020, okay, we can see that the grid part of the area has been completely spoiled by informal mining activities, and we can quickly see the difference between the Gaitu in 2015 and the Gaitu in 2020. So thank you for your attention, and if you want to contact us or to visit our site, here you have our address. Thank you very much.
Thank you. Thank you very much, Federico, for this excellent presentation. It's really great to have a visual perception of some of these images and to see what we can do with satellite imagery. So if anyone has a question, please feel free to use the Q&A box, and I'm sure our panelists will be very happy to respond to them. So our next presenter will be Mike Otieno, who is an associate professor in the School of Civil Engineering and Environment at Wits University in South Africa. Mike, thank you very much for joining us today. And yes, please start your presentation now. Thank you.
Thank you, Chair, for the introduction. Okay, I'm going to basically, thanks for the opportunity to present to start with, Luca and Joseph, the organizers, and the wider panelists. So a number of things that I'm going to touch on in my presentation now have been touched on by previous presenters and those that will come, but my presentation will basically try to collate all this more or less into a lecture onto the aspects that we need to think about when we think about making concrete more sustainable. So that's going to be the focus of my presentation. Before I start considering the wide diversity of presenters that we have, I thought it wise to just give us a short overview of what concrete is. We already heard earlier today that concrete is a commonly used construction material, and it is the most commonly used one. And it is still the most preferred. There is, you remember in the morning, Kolawale informed us that there is no replacement for concrete as yet. So just to bring us all in the same page, we know concrete is a mixture of cement, aggregates, fine and coarse aggregates, some extenders, which we will talk about later on. We also have admixtures and water. I put water in parentheses here because water only comes into play when we're talking about conventional concrete. Otherwise, when we start to talk about other types of concretes, like, for example, geopolymer concrete, alkali activated concrete, then water doesn't become really necessary. What is most important is that these ingredients of concrete are, of course, proportioned in an optimized manner so that we can meet both the desired fresh and the hardened properties. So that's basically what concrete is for those who really are not so familiar with this material as such. So the reason why we use concrete is widely known. It is a versatile material, high strength to cost ratio, good fire resistance, it is durable. And whether it's sustainable or not, yes, I think it is sustainable. And that is why the title of my presentation says we want to make concrete more sustainable. The reason why I say it is sustainable is because if you look at, or if you compare concrete with other construction materials, like, for example, timber and steel, you will find that concrete, for the benefits that we get out of concrete, the technical benefits, we still really can consider concrete to be a sustainable material. Even if we look at its carbon emissions and we compare that to other materials, if we were to for example, construct a structure using timber or steel and compare that to one made using concrete. If you compare the strength to cost ratio that you would get from those materials with that of concrete, you would still find that concrete is relatively more sustainable than those other materials. Nevertheless, we still have some challenges. Of course, the challenges that concrete has as a construction material is that there is, of course, increased demand, especially in developing countries in Africa, in Asia, and in other parts of the world. So we need to really be more efficient in the use of our resources. So that's one challenge that we have, the increased demand. So the next one is about the poor understanding of concrete. And this goes back to basically our curricula, the types of the level of experience in terms of the engineers that we have, the knowledge of the material, how it behaves, its properties, compatibility with other materials, and so forth. So this is one challenge that we have. We also have a challenge of the need for much more extended service lives of our structure. And this talks directly to durability of our concrete structures. We have now clients demanding for 100 years service lives that are maintenance free and so forth. Then, of course, one which is more relevant to this presentation is the need to make it durable and, of course, more sustainable. And this is basically what most of when we talk about finding alternative materials for making concrete, this is where the crux of the matter is, really finding these materials and making sure that they are sustainable in terms of both environmental footprint and other factors that we will consider. So what are the sustainability issues, or what I refer to as challenges that we have at present? They could be directly or indirectly related to concrete. As such, the one most common one is the cost, of course, and this cost relates mainly to the plain Portland cement. That's a conventional cement that we use in most developing countries. And we know that cement is the most expensive ingredient. Then we have water. Water is also a very scarce commodity in Africa, in developing countries as well in general. So then aggregates is also another important aspect that we need to really think about. We just saw from the previous, just immediate presentation before this one, how damaging we can be to our environment in terms of mining activities, whether it's in terms of mining of materials for making cement. In this case, I'm talking about mining or exploring extraction of mineral and natural aggregates from our virgin rocks. So this can be damaging to the environment. We also have admixtures, chemical, both organic and inorganic admixtures. These are known to have very high carbon footprints, and of course they damage our environment. And that's why we say that, of course, concrete as in general has a very negative impact on the environment as it stands. And then, of course, socially, there are also some social aspects related to it, which we tend to sometimes not take into account when we talk about sustainability issues relating to concrete. And we will talk about this in a moment. So these are the challenges that we need to talk about, and we need to really face and find solutions to when we think about finding alternative, or what I later on call non-conventional concrete making materials. So then this leads us to what I refer to then as the sustainability complex. So we have a lot of challenges, and the challenges that I have already mentioned, they're all interrelated and very complex to address. We have the environment, plain Portland cement is the main one to talk about here. During its manufacture, we just saw from the previous presentation how it can be damaging to the environment. Water, I've already mentioned, is a very scarce resource. And then we have economic aspects, cement, admixtures. Then we can move on to the technical aspects. We need to think about the strength and serviceability and the durability of concrete. And then when it comes to the technical aspects, other factors that we need to consider relate to the standards and all the design codes that we use as such. Then on the social aspects, we may not be very much alert to this, but there are serious consequences or effects when it comes to, for example, using alternative or non-conventional concrete making materials. There could be unemployment related to that. It could affect people's social well-being, things like housing and sanitation. I was looking at UN Habitat's vision, and they state their vision as being that to create a better quality life for all in an urbanizing world. So we heard from the UN Habitat presentation earlier in the morning. So we really need to think about all these aspects, and this is why I call it from a concrete perspective, concrete interest perspective, a sustainability complex. And we really need to think about all these aspects together. So when we start to think about alternative materials for making concrete, so then we think about what are the alternative materials in terms of cement, in terms of water, in terms of aggregates, in terms of admixtures, and what are the economic effects of these alternative materials. So these are the things we need to think about. And we need to be aware that when we use alternative materials or non-conventional concrete making materials, these materials will definitely have direct or indirect impact on each one of these sustainability pillars: economic, social, economic and environment, and then of course technical aspect is quite important from an engineering point of view. So we really need to think about this carefully, and that is why my proposal is that we really need a transdisciplinary approach. Okay, so we really need to integrate the natural, the social, health sciences in a more humane or in a humanities context, so that we can basically try to find a solution that is, of course, it may not be the optimal solution, but one which, for example, is acceptable to the community which that material is being proposed. So I'll just now move on to another topic in terms of some fundamental aspects that I think we really need to think about when we start talking about alternative materials or non-conventional concrete making materials. So the first thing I thought of doing was to basically give a definition of what this material is for those who may not be conversant with this. So I have defined here an alternative or non-conventional concrete making materials as one which can be used to partially or fully replace an ingredient for concrete making. Okay. So, and what is important is that it needs to do so, it needs to be used in a way that it doesn't compromise both the hardened short-term and long-term concrete properties. So that's the definition of an alternative or non-conventional concrete making material. But not all materials that will meet this definition will qualify to be an alternative material. I'm sure the question is then why? We will come to that, but just to start on with, we need to consider other factors as well. The first one being cost. What is the cost impact in terms of it may, for example, have a very beneficial cost in terms of reducing the cost of concrete, but what is the cost of it from a social point of view? We need to do that and find out. I mean, sometimes we only think about the cost, for example, of an alternative material in terms of how much cement is used to replace it. It replaces in concrete, but we don't think about, for example, the life cycle costing of that material, which is quite important. We also need to think about the availability of this material. When I talk about availability here, I'm talking about the quantity, whether in short term, long term, and of course, where it is located. So I'm not trying to infer that we need to have an alternative material or a non-conventional concrete making material in large quantities for it to be viable for use as a concrete making ingredient. Sometimes it may be just important to use it for a once-off project, but the gains that you get from that, people can learn from it. So we should not look at availability in terms of having it in large quantities. We just need to, for example, if, for example, you wanted to build a small structure once off, you really don't need a large quantity of for example, if you were using rice as ash, it could be enough to just complete a small or part of a project. But so we really need to think about those types of things, not necessarily from a long-term perspective. And of course, related to that, we really need to think about the opportunity cost. So this may be directly or not directly related to the concrete itself. So when I talk about opportunity cost here, we need to think about what am I foregoing in terms of when I choose to use an alternative material, what is the opportunity cost in terms of what I'm going to lose? And does it warrant me using that alternative material? So that's what we really need to think about. We should not confuse this cost with the opportunity cost with the cost. These are two different aspects that need to be looked at differently. And then we also need to think about the validation of these materials. Validation here in terms of its performance. Performance in terms of, for example, engineering properties. Has there been local research that has been carried out? You will find that in some cases, you will find these alternative materials are I would say, imported from their locality, and research is done somewhere else, tested somewhere else, and then the outcome of those research studies are then exported back to where the material was imported from. So that's it's more or less beats the purpose of it, because these materials need to be tested on the ground where they're supposed to, where they are going to be, or where they are expected to be used. And then, of course, finally, the social impact is quite important, whether you can have a very good material to be used as a replacement, for example, let's say for aggregates or for cement. But if the community does not accept it, and this has happened a lot in many parts of different countries, all the research that you've done may just end up to be if not useless for that matter, because the community was not involved. And so this is why all these aspects need to be really put into account. So when we talk about things like availability, I've already mentioned the short-term availability is not necessarily a bad thing. The social impact, acceptance by the local community, and of course, to do this, sometimes we may need to construct prototype structures to show them that this thing can work, and we can also use them, and as such. So we can be an example in terms of using those materials and constructing our own structures using those replacement materials. And then validation by local research, this is quite important, and it stimulates new ideas. We usually, as I've already indicated, it is not really a good thing to import the outcomes of other researches done on local materials without necessarily validating them, especially when we take into account the environmental, the environmental exposure aspect. I've already spoken about the opportunity cost, so I think I will not go into that again. And then, of course, when we talk about the cost, so we need to think about the cost of processing and the reproducibility thereof. So, for example, in the case of, let's say, calcination of agri-based materials or bio-based materials, we need to think about the processing aspect. How are we going to process this material, and how are we going to ensure consistency of the, for example, the ash that we are going to obtain, which means then we need to think about the reproducibility of these processes. And of course, availability of local technology is quite important. What is also quite important is the need for flexibility, or what I also call elasticity of local standards of design, or just codes of practice in general. So we tend to be a bit fixated in terms of using standards and not being able to think, I would say, out of the box, which is quite a dangerous thing in this world that we live in today. So we really need to have open minds and negotiate, be able to negotiate standards in terms of using alternative materials. And what is important here to note is that we really need to understand that standards are always work in progress. So it is very dangerous to take a standard and use it as a final or as if it's not going to change. Standards change, they are revised, and we need to think about them as work in progress. So this is why, as basically as African researchers or people who do research in Africa, we really need to try and advocate for flexibility in the standards that we use, as opposed to, for example, just using standards like, for example, the Euro codes being adopted for use in Africa. Of course, you can always change a few things here, but it is much more important to really be flexible in terms of using standards in general to accommodate these alternative materials. And then what is also important is investing in long-term research using alternative materials. This is quite important. I don't think I need to mention this. It has been underscored a couple of times in terms of collaborations, sharing of research outcomes. And of course, I've already emphasized the need to localize research as opposed to importing the knowledge. And then we engineers, especially the experienced engineers, architects, and all, anyone in any discipline, when they have practiced their trade for a while and it works for them, it is quite difficult to change their mind. But we really need to invest in this. It's not an easy thing, and this is why then we need to work with social scientists who can then give us guidance on how to approach this kinds of problem. How do we change the mindset of those who are already in the trade and really find it difficult to use these alternative materials, okay? So sometimes you may find that the local community might be willing to use these materials, but engineers do not have that confidence to use these materials. Why? Because they don't have any experience, or it's not what they are used to. So it is important to really think about this. And then inclusion in our curricula, civil engineering, architecture. I know the chair, I think just in a few presentations just before this one, it was said that things like sustainability become like things that are very strange to students when they go into postgraduate level. These things should be incorporated in the undergraduate curriculum. And in relation to this, we really need to encourage or support innovation and entrepreneurship, because it is only by doing this that we can really encourage researchers or novice researchers, emerging researchers, and so forth, to really explore new alternative or non-conventional concrete making materials. And this goes hand in hand, of course, with our new building technologies, prefabrication, and so forth. I will not underscore again the need to involve other stakeholders, including social scientists and so forth. But what is also most important is to really reconsider or think about how we test these materials. Do we continue to use the conventional ways of testing these materials? What are the available test methods, and are they suitable for concretes that are made using these alternative materials? So these are the questions we need to think about. I'm not saying they're not suitable, but sometimes they may not be suitable, or they may be suitable to some extent. So we really need to be very objective in terms of the test methods that we use. So I'll just go through some of the materials that we can replace in concrete. Of course, cement, some of these have already been talked about in the previous presentations. Bio-based or agri-based materials, and I've already indicated the challenges that we have with this, the calcination problems, how to maintain reproducibility of these ashes is a problem, especially when we do the calcination in open air furnaces as opposed to kilns or closed furnaces where temperature is and the rate of cooling, rate of heating can be controlled. We can also use other wastes. The intention here is not to give an indication of all the types of waste that we can use for making cement. Of course, I'm sure you may have heard of the LC3, the limestone calcined clay cement. Whether it is useful in terms of being applicable to the African continent, this is a question that we really need to think about before we indulge in investing in it. Of course, water is something that we can replace. When I say replacing water, especially in conventional concrete, I'm talking about limiting the use of potable water. As I've already indicated, water is a scarce commodity, especially in Africa. So we really need to think about how to minimize the use of potable water. So sometimes you go to a very large construction site and the water that is, for example, being used to clean the tools after construction. This water is let to go, but it could ideally be reused the following day to make new concrete, because it is not, that water is not really deleterious to concrete as such. So these are the kinds of things we really need to think about. In terms of aggregates, we can use recycled concrete, aggregate clay bricks, and so forth. The challenge here is ensuring consistent quality. And this has been the main challenge in terms when it comes to using recycled aggregate concrete. How do you ensure consistent quality? How do you sample your aggregate for testing and so forth? There are, of course, industrial waste materials, blast furnace slag. We can also have some agri-based byproducts or agro or bio wastes and so forth. And then in terms of admixtures, there are plant-based or bio-based admixtures that can be used, as opposed to using the chemical admixtures that, as I've already indicated, have very high carbon footprints. So we really need to think about some of these things. And we can only be able to know of these plant-based or bio-based admixtures if we allow for innovation, exploration by novice researchers. And of course, what is also most important is to ask yourself the question of replacing more than one material in concrete. Is it possible? That's a question I will leave as food for thought. So just to close, I want to mention that as we look for alternative materials, we really need to think about two things. One is sustainability and resource efficiency. That's quite important. We are not looking for alternative materials to replace conventional ones for making concrete just for the sake of it, so that we can use the word sustainability. We also need to think about resource efficiency, which is quite important. And then we really keep in mind what I'm calling here pillars to implementing alternative concrete making materials. We need to educate our engineers and also our students in institutions of higher learning. And this relates also to research. We need to encourage and support innovation and entrepreneurship, especially amongst the young researchers. We need to encourage flexibility. This is something which is quite difficult, but of course it goes hand in hand with the mindset change. Whether it's engineers, architects, scientists, and all other professions, social scientists, and so forth. And of course, flexibility or elasticity, as I mentioned before, in terms of standards, codes, and so forth. What is also important is another pillar is collaboration. We need to partner with each other. We need to share the information that we have. Open source publications are quite welcome, especially when it comes to sharing of research outcome. And then finally, we need to involve all stakeholders. And when it comes to involving all stakeholders, to me, the most important one is the local community where these materials are intended to be used. I will end my presentation there. Thank you.
Thank you very much, Mike, for this really interesting presentation. And yes, and the points you touched on at the end, I think they are so important, particularly in terms of involving local communities, because I think they are often the ones missing within the debate. And they are the ones who often also are the most impacted by this. And I think the change of mindset is also important, because often local and indigenous knowledge or way of doing things before is often ignored. So yeah, so thank you very much, Mike. Now we're going to have Alistair March, and Alistair is a postdoctoral researcher at the University of Leeds, working on alkali activated cement as well as the use of clays and soil in other types of construction. Thanks, Alistair, for joining us today. And yes, and you can start your presentation. Thank you.
Hi, sorry, excuse me. I'm co-presenting with Marusha Nambatya. Could you introduce her, please, as well?
Okay, thank you.
Thank you.
Should I go ahead, Alistair?
Yeah, just to say one. So yeah, I'm presenting with Marusha Nambatya from HYT Uganda. Unfortunately, between us, we have some connection issues, so we're going to play a pre-recorded video, but we will both be online to answer questions over Q&A. Thanks.
Good afternoon and welcome to our talk today. Our topic will be on interlocking stabilised soil blocks, looking at research, resources and client requirements. So we'll start with a brief introduction to the technology itself, then explore some of the technical challenges for how we can improve the product, and finish with an exploration of the other challenges and opportunities for achieving wider adoption. I'm Alistair Marsh from the University of Leeds, and I'll be co-presenting with my colleague Marusha Nambatya from HYT Uganda, who I will now hand over to introduce the technology.
Okay, thank you so much, Alistair. Just for the audience present, I would like to give a brief introduction to the ISSB, which basically is a compressed earth block that is stabilized with cement, and it includes a mix of soil and sand. The block is compressed in a manual machine and put to be cured rather than fired. Haileybury Youth Trust, HYT Uganda, is an organization that trains youths in how to make the interlocking stabilized soil blocks and build various structures using the same, hence improving the livelihoods of the youths that are involved in the training programs. We work across the country, Uganda, but most currently we've done most of our projects in refugee settlements. Next slide, please. ISSB is broadly used. We have two versions of it. We have the straight ISSB, which comes from a straight mold, and the curved ISSB. The curved ISSB is what we use when we are constructing rainwater harvesting tanks. Same ingredients. The difference is in addition of a waterproofing agent in a mix for the curved ISSB for water tanks. Otherwise, the ISSB is broadly used in school buildings, housing, staff accommodation, perimeter walls and kitchens. In HYT work, we fulfill a number of sustainable development goals, including climate action, given that the ISSB is environmentally friendly without need for firing and simply cured. And in the communities where we work, we give sustainable communities that are well trained in how to use the ISSB and the importance of using ISSB versus firing the bricks, and a number of others like industry innovation and infrastructure, through construction of water tanks, clean water and sanitation, and quality education to those who are the beneficiaries of our training program, as well as those who are the beneficiaries of the structures, school structures that we end up constructing. Next slide, please. I'll let my colleague Alistair speak about the technical performance of ISSB.
Thank you, Marusha. So when evaluating the technical and environmental characteristics of ISSB, it really has to be done sort of in comparison and in context with the two sort of dominant materials for building comparable structures in Uganda, that is concrete blocks and fired bricks. So in relation to concrete, ISSB have a slightly lower cost and a slightly lower cement use. And in comparison to fired bricks, there's no need for firing, and hence there's no deforestation, which is a large issue for Uganda, from the cutting down of trees to fire brick kilns. A kind of unique selling point of ISSB in terms of the resource supply is that all the soil used is sourced on site. So in the next few slides, I'll explain some of the opportunities we've identified for improving the product of ISSB from our work on this project so far. And this is around two components of the block: the cement and the sand. So for a long while now, ISSB practitioners have been wanting to really minimize the amount of cement used, albeit whilst maintaining the same material performance and confidence in the product. This is both to reduce the cost. Cement is the most expensive material component and also results in the flow of money out of the region and country, and also to reduce the embodied carbon. To try and address this, we're currently investigating the use of rice husk ash as a cement replacement material. Of course, many of you will be familiar with the use of rice husk ash as a cement replacement in concrete, which is scientifically and technologically very well established. However, use of rice husk ash in compressed stabilized earth blocks offers particular questions and challenges. In particular, these blocks are not cast like concrete, they are compacted. So we need to understand the role of the rice husk ash in affecting the optimum moisture molding content, the compaction behavior, and therefore the ultimate effect on compressive strength. We would expect that the optimum range of replacement would be the same as in concrete, so approximately in the range of 10 to 20%, but this needs to be tested and established. And lastly, we're also curious and open to using other agri-ashes, for example, cassava peel ash, which I know that other people in this call have a lot of knowledge and expertise in. So aside from those sort of technical points, through the course of planning these experiments and undertaking them, we identified several resource-based sort of challenges as well. Firstly, ISSB are always made on site rather than in a centralized facility. And this is good for many reasons, but because there are therefore very limited facilities, there's a question about how best to test the quality of sources of rice husk ash, particularly new sources. From our dealings so far with companies which incinerate their husks to power boilers, it seems that there's some variability in the composition of what they burn. For example, the proportion of bran compared to husk. So this is a question, how best to manage the variability and that supply. And lastly, whilst incineration of husks for sort of energy production is widespread in some parts of Southeast Asia, it is not yet widespread in Uganda, perhaps partially due to the fact that agriculture is not widely mechanized in many areas. So there's a question here about how best to source ashes when large scale supplies are not widespread, are not available in a particularly widespread manner, and how to best sort of manage those supply chains for an individual site. Lastly, as Marish mentioned before, sand is used in ISSB to achieve the optimal particle size grading and therefore to get the best mechanical properties. But we can't ignore the fact that, as in many other parts of the world, sand extraction does cause ecological harm. So questions we're recently asking ourselves is, can we reduce the amount of sand needed, but while still maintaining technical and environmental performance? And building on recent research in concrete, recycled concrete and other materials, can we use more sustainable alternatives? For example, recycled materials or byproducts instead of using naturally extracted sand. I'll now hand back to Marisha to explore some of the other challenges and opportunities for wider adoption.
Thank you, Alastair. Indeed, there are other challenges and opportunities for improvement, and I'm going to speak majorly about 4: what it takes to convince clients, how architects need to be empowered, the impacts of government policy, and sustainable livelihoods. So if you would go to the next slide, Alastair. So when it comes to convincing clients to adopt interlocking stabilized soil blocks as a construction material versus using fired brick, this has proven to be a long, continuous process so that you can build the confidence of the client. There's back and forth convincing members in the head offices, those in the local offices, having members to visit some of the completed projects to have the seeing is believing experience. And obviously this directly affects the tendering process because many of them are very prescriptive. They are very prescriptive to the conventional materials such as fired bricks, and they specify fired clay bricks. So that in a way already eliminates the introduction of novel materials like ISSB, and it takes a whole different angle to actually get a buy-in from the clients, which includes having to partner with them and maybe then not have to go through the full tendering process. So that's one of the challenges we've encountered with making sure that ISSB is used in the structures for different clients. Second slide is on empowering architects. So when it comes to architects, they have a very key role in specifying materials that are going to be used in construction, and they do that clearly at the design phase. And whereas they do it at the design phase, many of them lack the confidence in specifying some of these novel materials, particularly because they are not engaged, sometimes are not engaged throughout the construction process. So, and therefore they don't have the practical experience of seeing the novel material being implemented. So it would really, really be beneficial to see that some of these novel materials like ISSB are included in the university curriculums to begin with. And then those in practice who have had experience using novel materials in design. For example, if you look at the right-hand side, the top picture, there's a design by the Richard Feldman Foundation. And the architects designed, they specified the product, they oversaw the implementation phase up to completion of the project. And them sharing their experience with other architects is very useful to actually see more of the work of to see more of these materials being included in the designs and specified. And once we see architects being involved beyond the design phase into the construction, we believe that we shall have more and more people, more architects specifying novel materials in the design of their different structures. Next slide. Yes, this is a long shot, but it's really possible. We see it as something possible, government and organizational policy. Imagine that large clients or funders like the UNHCR had an appreciation of the impact of construction materials on the environment. For example, the impact that fired bricks have got on deforestation, for example, that would be that will create more awareness in being able to look beyond just simply funding a project. It would create an opportunity for the government and the organizations to reconsider what's in their policies, especially when they put out tenders. And it will be very interesting to see that for the materials that are being used in construction, all the materials that are being used in walling are all checked for environmental performance. And we feel that if the government could go ahead and put a ban on deforestation for brick kilns, it will be a great step towards adoption of ISSB in the general construction in Uganda. Next slide, please. Sustainable livelihoods is also another challenge. You would imagine that given that HYT trains loads and loads of youth, young men and women, over 500 as we speak, you would imagine that they go on to build more ISSB buildings. However, because there is not a wider demand for buildings constructed with ISSB due to the limitations I already mentioned, tenders being prescriptive to fired bricks, then you find that many of the trained youth do not actually use the specific skills, the ISSB specific skills. Well, the good news is that they learn every aspect of construction, from preparing the foundations, excavations, and plain walling, all the way to roofing and the other skills around making floors, installing windows and doors. So yes, they actually get transferable skills when they get to work with other construction companies, but they may not necessarily all be practicing construction using ISSB. And then as a small NGO, the Haileybury Youth Trust is limited in the scale of projects that we can deliver. So for it to be widespread, we would need to have more organizations looking into ISSB as a skill or a trade that they need to also have, in addition to all the other construction using conventional materials like fired bricks and concrete. Next slide, please. Yes, having discussed those challenges, I just wish to conclude by mentioning that indeed ISSB has good sustainability performance in Uganda, and this is proven by the number of projects we have completed, that the savings in the number of trees not cut down, and we see that there are opportunities to improve the costs as well as the embodied carbon of the interlocking stabilized soil blocks. And we are open to any collaborations out there that see this as an opportunity to get to improve this novel material. And there are also opportunities to overcome barriers to adoption of novel materials. And it will be quite interesting for us to hear from other members present how they've managed to bring about novel products into the commercial construction industry. Otherwise, I want to thank you so much for listening to us in this presentation. If you have any questions, our contacts are given. And we want to send out our special thanks for the funding we've received from Building Research Establishment Trust, as well as the Worshipful Company of Constructors, for the project that we are yet to experiment in the use of rice husk ash as a replacement for some of the cement in the interlocking blocks. Thank you very much.
Thank you very much, Mauricia. And I'm really sorry I missed to say your name earlier with Alistair. So thank you for the excellent presentation and the excellent work that you are doing, because I think we can all be here as academics and talking about all these great ideas. But as Mike said earlier, it's about how do we localize these things? And the only way to do that is by involving young men and women. And this is exactly what you are doing. So I must say congratulations. And you are showing how important it is also to collaborate with academia while doing this. So yeah, congratulations to you for doing this in practice and for training many young people in Uganda. I hope this is something that can be extended to other places in Africa as well. So thank you very much. So next we're going to have Rain Isaacson, who is an associate professor in quality management at the Department of Civil Engineering at the Uppsala University in Sweden. Welcome, Rain.
Thank you very much. I hope you can see my screen and hear my voice. Okay. So thank you for the introduction and thank you for being invited. This presentation is a bit different, maybe. I'm actually glad to hear that so many people are interested in cooperation. And one of my objectives here is to see if I can find somebody to work together with in taking this idea of sustainable building in Africa a little bit further. So the presentation is titled Opportunities for Alternative Binders in Block Production, the case of Sub-Saharan Africa. And this is because I think Sub-Saharan Africa, by many reasons, is the area that is needing the development most. And because, as we have heard, there are quite some great problems with the Portland cement that we use. So just putting us on the place somewhere. So Uppsala University is often ranked among the 100 highest ranking universities in the world. It has 12 campuses. 11 of them are situated in Uppsala, just north of Stockholm. We are on the island of Gotland, the largest island in the Baltic Sea. It's a small campus and the island is only having 60,000 inhabitants. We are having 2,300 full-year students here. And what is different from us compared to Uppsala University is that we are the previous Gotland University and we have mainly teaching here, but we are expected to increase our share of research considerably. Uppsala generally has 60–70% of their financing for research. We have much less, and in the division of quality management, we have practically nothing. So our head of department is pushing very hard to increase the share of research, which means that we need to, of course, find the funding, but we also need to find the researchers to do the work. Gotland in the summertime, it's one of the largest tourist destinations in Sweden, so we double our population. But it's a short period of the summer season, 3 months. The rest of the year, it's maybe a little bit gray, but it gives you good opportunities for studies and research. So I call them research development questions a little bit rhetorical, because you think quality management, so what does that have to do with building? Well, quality management is something which is part of all kind of improvement. And I think what we bring into the party is our focus on customer needs and the stakeholder needs. So we start from the outside in, looking at what is needed, how can we help? So we provide a kind of a managerial suit, a kind of a catalyst for improvement in different areas. And we are very well we have good conditions for it here on Gotland, because there's a high-level agreement between Uppsala University and the region of Gotland that we use this as a living lab in seeing how Campus Gotland can support the sustainability of Gotland. But obviously, Sweden, being one of the most sustainable countries in the world, still needs to improve. But we also need to be part of global sustainability. And there, Uppsala University has a goal to make a real impact in sustainability, which means that there's an interest for working also globally. So the idea we've been toying with here is that could we somehow make this small campus to kind of a hub to support sustainable building in Sub-Saharan Africa as an example of support to sustainable development in other fields, as varying as food production or tourism or healthcare. But could we make sense into this with building and then choosing the area where we think that sustainable development is needed the most? And then still narrowing it down to the alternative binders. And we'll try to, in brief, explain why I think this would be the kind of a crucial part to start from. I think it's always good to have a concrete example to generalize and understand the kind of a general picture of what we're talking about. So if we start from some kind of a needs basis, so when we look at sub-Saharan Africa, we can see that this is an area we were expecting an enormous population growth, almost 3 billion more people from now until the year 2100. And those people, most of them are already born, so there's not much we can do about it. People will live longer and there will be more of them. So this, of course, brings us to the next question: where will they stay and live? So if we assume that this development also will benefit sub-Saharan Africa until 2100, we then should see that people actually are getting the accommodations, the dwellings that they need, which means that in the same time as the population goes from 1 to almost 4 billion, the per capita cement consumption should go from about 100 kilos to something around 600 kilos, which is close to the global average now. And North Africa currently is having like 600 kilos per person. So what does it mean? It means that from about 100 million tons of cement per year today, we will use maybe more than 2 billion tons. Now, this is almost half of the global production, and we know that cement is responsible for some 8% of the carbon emissions. So this is not very feasible unless we use the cement in a very good way. So therefore, what can we do with the Portland cement into using it better, or can we substitute with something else so that we don't cook the planet while providing the developments that people need in sub-Saharan Africa? So residential building, I think, is in focus, because if we go to people's need, okay, we need infrastructure and there are some high rises. But when we look at Africa, there's plenty of space. We can see the urban sprawl all over. I think this might be flying into Dar es Salaam. But residential building for the majority of people in sub-Saharan Africa is a slow process involving block-based materials. It could be burnt bricks, it could be soil cement. Increasingly, it's cement-based blocks. And why is it like this? Because almost nobody has the financing of building the house directly. You build a house over 10 to 15 years. So you do a portion at the time. I get some money, I buy 3 bags of cement, I do the blocks, and in 15 years I have a house. So sustainability, residential housing sustainability is a question of having sustainable building blocks. And in most cases, it is then going back to having sustainable cement to make those blocks. Now, a little bit going back, so why did I come into this? I'm a chemical engineer, I have a PhD in quality management, so why working with blocks in Africa? I had, I guess, a midlife crisis. I did a PhD late in career, and then after a conference discussing knowledge management in Kuala Lumpur, I went to Pancor Island for 3-4 days and tried to see how could I contribute and what would be my comparative advantage. Now, I worked 10 years in different African countries as production manager, technical director in cement manufacturing, also quality manager, laboratory supervisor. So I thought, okay, I like Africa, something in Africa which has to do with building. And quality management, surely I should be able to improve those processes which are there. And then I also worked as consultant within cement process improvement in the Nordic countries and in various African countries. So the solution was block excellence. And I wanted to start in Tanzania. I spent 2 years as a volunteer there ages ago. I speak some rudimentary Swahili, so I thought that could be a good place to start. So trying to make sense out of block making, and this started more than 10 years ago when I was on a consultancy trip to Dar es Salaam, and I stayed another week to try to see and understand, so what is this about block production? Remember, I don't have any construction background, so I thought at least making the sand cement blocks doesn't seem so technically complicated. I would be able to learn that in practice. And so just some examples. I've had some people doing a minor field study at this time. We started looking at, in Dar es Salaam, 60% of the cement goes to blocks. I think about 1 billion blocks are produced yearly, and most of them, 90%, are solid blocks, where the cement is quite poorly used. So one idea was actually, could we convince people to use hollow blocks? So I had these 3 students from Sweden looking at what stopped using the hollow blocks. It was hard. I think it's a lot in people's attitude. Sometimes people that don't like them, they say, oh, you can punch your hand through it, or you can shoot through it. No, we want to have a solid block. The production of these blocks, there must be something between 1,000 and 4,000 of these small producers. The equipment they produce themselves. It's all mechanical workshops, and then the technological development is not so much. So they call them vibrated blocks, the matofali that are produced. A lot of manual work, as here you can see the dosing of cement, half a bag of cement, well, it could be 23, 27 kilos. So there's a big variability in the results. And the challenge, 5% of cement and then sand and water. So how do you make good use of cement when it's only going to be 5%? Well, I thought, I mean, with the background I have, that it should not be that difficult to come up with some improvements. It has proved much more difficult than I thought. So trying to do some sense making, and this is definitely a wicked problem, and I think it has been mentioned in this work session that we need transdisciplinary and cross-disciplinary work, and it's not only a technical problem, there's always admin, cultural, other issues in it. So you start with Dar es Salaam, 70% are basically squatters, as we saw in one of the pictures. I think if it was with the visual imaging, you can see that houses are just built randomly, and that's how it happens in Dar es Salaam, which means that there's basically no documentation on it. So what is the problem? How can we measure? How will this cement used? We don't know really, because nobody measures it. So understanding the problem at first, to put figures at it, it requires you actually going out to the site, measuring yourself to find the values. And then, like, defining block sustainability, what is it? We heard here earlier about concrete sustainability. I have maybe a slightly different opinion there. I think when we speak about buildings globally, they consume something like, or are responsible for 40% of the carbon emissions. And climate change is one of the crucial problems. So for me, building sustainability must include that we are aiming at the zero carbon footprint. Carbon footprint is definitely one of the critical environmental issues. But another thing is affordability. It has to be affordable for people, so it has to be cheap. So money, what do we pay for our blocks, our houses, is important. So in my world, the building, a sustainable building is affordable, having a zero carbon footprint. And a sustainable block, and there the value could be defined as I'm exemplified here, measuring the functional value is a square meter of wall which is good enough compared to the price and compared to the CO2. When we hear about the soil cement blocks, fine, but 7% cement is too much, because with 7% cement I can already make a very good concrete block, but the carbon footprint is still too high there. So here in the soil cement also, then, as we heard, if we can somehow substitute the Portland cement, we could then get both down the price and the carbon footprint. So after some 10 years of work, this is as far as I come. Not so good for a project where I maybe spent 2,000 hours going to Tanzania maybe 20 times. So the strength, obviously we measure it in megapascal. How do the customers measure it? Class here, my friend is demonstrating. You take a block, you smash it to the ground. Aha, it only broke in 3 pieces. So this is good. If you ask somebody what is the strength in megapascals, nobody has an idea, not even what a megapascal is. So what you don't want to see is when you throw this and it goes mush and it just becomes powder, then you know, this is not good. But I think at that level, you are probably down to 0.5 or 1 megapascals. As soon as it's more than 1 megapascal, it passes this simple test, but the customer doesn't know if it's 2 or 8 megapascals. It's almost impossible to know when pressing with your fingers and testing. So measurement is a big problem. That how can you improve when you cannot measure? Normally, what is measured is how many blocks do I get out of a bag of cement. 36-inch blocks out of a bag of cement is reasonable. 35 is even better. That means about 5% cement. These blocks are weighing about 30 kilos. But this is the same measure as for productivity then, and it assumes that the only thing which matters is the percentage of cement, which is not correct. We can see a big variation in the performance with the same amount of cement. But since blocks are not measured, this is often hidden. It's difficult to know that one producer actually is better than the other one because you are not measuring it. And normally there's no quality control. Out of all the places, there's, I think in Dar es Salaam, if there would be several thousand block producers, there would be maybe 5 that measure the quality performance regularly. And when going to Tanzania Bureau standards, to having some idea, and these are the better blocks which have been taken there for testing, which go to governmental projects or schools. Still, they come out with a variation which goes from 1 to more than 5 megapascals. And the standard basically says 3.5 as a minimum for the individual block, but 4 megapascals as an aggregated average for 5 blocks. So basically, most of these are substandards. But does it mean that they are not fit for use? Are people stupid when they buy them and build their houses? It might be turning out that what is stupid is the standard, which probably is inherited from a British standard somewhere, which comes from different conditions and maybe randomly has put the compressive strength requirement at 4 megapascal. Because if you think of it, 4 megapascals, that for a 6-inch block, that means that it can sustain 24 tons, a reasonably big lorry. Now, when you build a single house with a tin roof, you don't need 24 megapascals. Then the argument is, yes, but it's need for durability. But when you look at all these suburbs where they have been building with 1 megapascal blocks and nothing is falling apart and they stand after 30 years, then you think maybe the durability is there anyhow, but there's little research on this. So findings over the years, some kind of a conclusion for this, that the cement is very poorly used, and I will show you in a moment why. Maybe about 20% of what is used in good concrete has been used. So it means that we're wasting 80% of the cement building capability. So one of the questions I have is, could this actually not be improved? And the answer is not much. And that's why I'm repeating myself, we need to find alternative binder for these simple solutions. Cement should go to high rises, to demand it, to bridges, to whatever that demands its good capabilities. It should not be wasted on simple blocks that need a couple of megapascals. Cement standards are not relevant. We looked at this in Tanzania. So if we would increase the cement amount to what the standard or the megapascals to what standard requires, the only effect of that is that the cement becomes more expensive, buildings become more expensive, the carbon footprint is higher, but the functional value for the customers is basically the same. So standards are partly a problem. And performance varies significantly with the same level of cement addition, but this is often not perceived. And a few of the issues that have surfaced in all my studies, of course, is sand used, but they quite often customers cannot choose. They get the sand that they get. Where they could do something is the water addition. Normally too little water is added. If you think of it, if you have 5% of cement and 95% of sand, you need to put quite a lot of water to get that compaction. Otherwise there are big voids and the strength will be very low. But for those that produce these blocks, they are paid per rate and they do it as quickly as possible. So they optimize it for the speed of production, not for the quality of the blocks. And they wouldn't know because nobody is measuring. Sometimes vibration times are also shortened to speed up the production, which then reduces the strength. Now this is a curve I think you have seen is adapted. So the water cement ratio, and I've taken well, whatever typical concrete with 0.5 water cement ratio as the reference as number 1. But what happens when we have 5% cement? Now if you think of it, we might have to add up to 10% of water in order to get the sand matrix to compact properly. If I add 10% and I have 5% of cement, we end up with a water cement ratio of 2, or maybe only 1.5, which means that we only use about 20% of the potential strength of the cement. Now, could this be changed somehow? Well, maybe improve a little bit with hollow blocks, which I have tested, but not substantially. So this is a big problem that the blocks, the 1 billion blocks produced in Dar es Salaam and in many other countries, they use maybe 20% of the cement potential only. So all that emission is going there out for nothing because we use only one part of the capability. This is one of the latest research. This is together with Apollo Buregeya from Eco Concrete and Makerere University in Uganda, and the Ugandan samples are taken from his plants. He produces cement blocks with a higher cement content, which is to the higher end of the market, and he also charges quite well on them. And when you are this level of cement addition, then you can show that for the same functionality, you actually get more kilograms of carbon dioxide per square meter of wall when using solid blocks. So hollow blocks are better, but only when you are at the standardized and good quality blocks. When we look at Tanzania, and 90% of the blocks are solid, and this is kind of an average we have found, but in many cases blocks are even with a lower strength, but still providing the functionality. So the low performing solid blocks are having the lowest carbon emission, and they also are the cheapest ones. Hollow blocks here, in this case, we found some which were at the same level, but they normally are more expensive. They are more difficult to produce, more breakage. So the rapid review here of comparing, because I thought still, I mean, many people have said, oh, in my country, we only use hollow blocks because they are much better, and that's what often you see. But it is in a market where cement price is not so important as it is in many of the sub-Saharan countries. So the conclusions for the BLEX project, the Block Excellence project, is that from a user and from a climate perspective, the best solution is to use substandard solid sand plus cement blocks. Well, if you have aggregates available, you can improve the performance. In Dar es Salaam, they are not available easily, and so sand becomes the logical material to use. And down to 1 megapascal seems to be okay. Research is missing here. What is really needed? A 1 megapascal block, 6-inch block, still could carry 6 tons. So if it's put well in place, the compressive strength should not be a problem. Then the durability, well, their research I think is missing. Standard requires 4. So for higher performance blocks, when we go to government projects or where they do the measurements, where we need to fulfill the standards, then hollow blocks normally would be a better solution, which gives you both a better price or lower cement consumption per square meter of wall and a lower carbon emissions per wall. So my conclusion after all this, and I should of course have come up with it earlier, but maybe I'm a slow learner, is that Portland cement really cannot be used with high cement productivity. If we go down to these low levels of cement percentage, we use only a fraction of its building capability. If we increase the cement again, then we produce strength which is not needed. So the currently best solution is not a good solution, which then brings me forwards. And there's 2 things here with the future research. One is, what can we do with the blocks? I think still things could be done there. We could maybe improve the performance with 30 or even 50%, but that will not solve the big problem with the cement, as we saw, being produced in big factories normally costing something like $150 to $200 million. It happens in places in Tanzania that the cement is transported for 1,500 kilometers. We would instead need some alternative binders that can be produced in smaller local units that can perform well. But having said that, I think there's still work to be done. Looking at standards, are they actually applicable for the use that they are for? Here, I think there's still a lot of copying from Europe. I think the local standard authorities have a work to do. Then, how good is the cement performance in different countries? How many strength tons do we get out of our solutions? I claim that for the blocks it's low. How is it generally for other countries? This is also not known. The water addition, here there could be a simpler way, well, not a simpler way, but a feasible way forwards in trying to find the right water addition, which gives you the best compaction, but the possible lowest water cement ratio. There is an optimum. We tested it and we know that there's an optimum. And normally in those cases, I've seen too little water is used because those using it do not know what the results are. Hollow blocks also in some cases would be a solution. Here research would be needed. And then I think even when I listen to this conference and others, that the research is still dominated by an agenda defined by the European and Western countries. We should start more from the customer needs, going out to those residential builders. What knowledge are they needing and what are they opting for? Of course, we should have suggestions, but understanding their needs in greater detail, I think is very important. And that is the contribution from quality management, the stakeholder needs focus. So future research, and here I'm inviting you for taking contact with me. We have posted together with Wolfram Schmidt, and we have had Joseph Wheaty also participating. We have somebody from University of Dar es Salaam. I think we have Makerere with the Swedish Science Council for low cost and low carbon binders for block production. Not a very good application, unfortunately, but we know in November if we get it or not. Otherwise, in February, we can have a new try. So we're going to go for looking at the use of volcanic ashes, calcined clays, thinking of maybe substituting, not having any cement at all, but using free lime as activator and making block binder materials. Not trying to make an ordinary cement where we substitute 20% with some additives, but making a block binder, going directly for the blocks. It's not going to be according to a standard, but as long as the blocks are corresponding to the requirements, it's fine. So it's just being called a block binder, so we can divert the standard issue here. And then also, as was mentioned in the previous presentation here, if the soil cement, I think, would be good if we can substitute the cement, because when using the cement, the carbon footprint exceeds even that of the cement sand blocks. And we also have a networking call where we hope to see if we can get some appropriate technology ideas in. We're thinking of a cooperation, Sweden, India, Sub-Saharan Africa, in trying to get technology for producing these alternative materials, small units, which could be such that local businessmen can invest in them. And by that, I come to the last slide. Thank you very much for listening. And if you are interested, then welcome to Gotland. We do it virtually on Zoom, or you come and do it in real life. Thanks.
Okay. Thank you very much, Rens. And I think this is a great session to end on before our break. And one important point that you've highlighted is about affordability. And I think it's excellent that you are an expert in quality management, because I think for sustainability, we need affordable but good quality material, which often doesn't come. It doesn't always come together. But I think if we can get to that, it would be very good, and where as well other people are included. So thank you very much. It's been a really good session, I think, and very important points have been highlighted. from the importance of engaging local communities, working with young people, young women, but also collaboration and collaborating and interdisciplinary collaboration with earth scientists, social scientists, health sciences, earth sciences. So I think, yes, I hope that the collaborations will continue. And thank you to the organizers for bringing a diverse group of people together. And yes, I'll hand on to Luca. It's been a pleasure listening to everyone today.
Yeah, thanks, Penda, sorry. Maybe before wrapping up, am I active, not muted? There was a request for clarification in the chat. Can you maybe address this, Rainer? Was a request from Mark Bediaco.
Yes, I sent him my email and said it's easier for me because this will disappear now. So if he just emails me, I will send him a few papers to explain the issue.
Okay. Excellent. So I'd say we can go for a coffee break.